The natural minor scale has the following interval formula: 1, 2, flat 3, 4, 5, flat 6, flat 7. Let's consider the A natural minor scale, which has only natural notes. The 7 notes in the scale are A, B, C, D, E, F, G. In the ascending scale, there is a whole step or major second between the intervals 1 and 2, flat 3 and 4, 4 and 5, flat 6 and flat 7, and flat 7 and 1, and only one half step or a minor second between intervals 2 and flat 3, and 5 and flat 6. We can follow the whole step, half step formula for a natural minor scale to determine that there is a major second interval or 2 half steps between A and B, C and D, D and E, F and G, G and A minor second interval or 1 half step between B and C and E and F. The intervals in the natural minor scale, which are the same as the intervals found in the major scale, are the major second, perfect fourth, perfect fifth, and octave intervals. When you flatten the major third, major sixth, and major seventh degrees of the major scale by 1 half step, you derive the minor third, the minor sixth, and the minor seventh degrees of the natural minor scale. One common way of learning the natural minor scale is by using the caged system, which helps you connect scale shapes over the entire fretboard. Once you learn the basic minor chord shapes in the caged system, you can use the root, third, and fifth chord tones in these minor cage shapes as reference points to map out the remaining second, fourth, sixth, and seventh intervals of the natural minor scale. A more practical alternative to visualize the fretboard as intervals is to follow the NANDI method. Let's take a look at how this method can be implemented to identify intervals within the minor scale. With the NANDI method, you follow a pattern that is both uniform and consistent and in sync with the interval structure of the fretboard. Given that the standard guitar is tuned mostly in fourths, it only becomes logical that we adopt the same pattern to navigate the fretboard. When we arrange the intervals of the minor scale in fourths, we derived intervals 2, 5, 1, 4, flat 7, flat 3, flat 6. Putting these intervals in any other order means that we will encounter a tritone or an augmented fourth between intervals flat 6 and 2. An augmented fourth is simply a natural fourth raised by a half step or 1 fret distance on the guitar. By keeping the 6th and 2nd scale degrees far apart and on either ends of the interval pattern, we can have a strictly perfect fourth pattern. The best part is that we can easily locate the entire scale in the exact same order on the fretboard in an almost linear fashion. To plot the natural minor scale in the E shape, for example, we must first locate the roots in this shape. One of the roots can be located on the 2 E strings, while its octave is 2 frets higher on the D string. Since our fourth pattern for a minor scale starts with 2, we must find its location within the E shape. We could simply move up 2 frets from the root on the E strings to find the interval 2. Or we could use the NANDI method of using intervallic relationships between a pair of strings as a reference point to figure out an interval's location. If we want to start plotting the scale in close proximity to the root on the higher frets of the shape, which would be the root on the D string, then we can use the major second interval between the open notes D and E as a reference to locate a major second from the root on the same fret of the E string. Starting from 2 on the E string, we can plot the intervals 2, 5, 1, 4 on the E, A, D, G strings. We must factor in the odd tuning of the B string and make a 1 fret up adjustment when going up a fourth from 4 on the G string to flat 7 on the B string. Continuing up a fourth from flat 7, we get to flat 3, which can be found on both the E strings. Finally, a fourth up from flat 3, which is flat 6, can be found on the same fret of the adjacent A string. We have just identified the intervals of the minor scale that is closest to the highest root location in the E shape. Now we can go up an octave to locate the other instance of the two 3 frets lower on the G string, or we could implement the NANDI method. The minor third pitch distance between the open E and G notes indicates that any two notes or numbers on the same fret of the E and G strings will also be a minor third apart. This means that a minor third from root 1 on the E string, which is flat 3, can be located on the same fret of the G string. Using flat 3 as a reference point, we can now locate 2 on the G string, 1 fret below. Beginning with 2 on the G string, we can plot the remaining fourths. Take note that the fourth from 2, which is 5, falls on the B string. This means that we can make a 1 fret up adjustment from the G to the B string to compensate for the major third tuning of the B string. 1 is a fourth up from 5 and can be located on both the E strings. From 1 on the low E string, we can find adjacent fourths 4, flat 7, flat 3 on the same fret of the A, D, and G strings, and flat 6, 1 fret up on the B string. You will notice that all the intervals in the lowest frets of the scale shape have been plotted within a 1 fret distance of the lowest root in the E shape. Similarly, all the intervals on the highest frets are also within a 1 fret distance of the highest root location. You have just learned how to plot the natural minor scale as 2 layers of fourths, which, when combined, is the entire natural minor scale in the E shape. Whether you are soloing or improvising and want the ability to access an interval almost instantly, the NANDI method is the only practical approach to visualizing intervals in close proximity to the root, which would otherwise take years of playing to master. We will now plot the E minor scale in the E shape, which we used earlier. This time we will use the letter notes instead of intervals. Take a look at the pattern of notes. F sharp, B, E, A, D, G, C on the higher frets of the E shape. Now we see the same pattern of notes starting from F sharp on the lower frets in the E shape. You will once again notice that each set of fourths are within a 1 fret distance from the root. Combining the two patterns, we can see the entire E minor scale in the E shape. There you have it, the natural minor scale with the NANDI method. To practice the natural minor scale from every root in all the 5 cage shapes, we recommend the app Natural Minor Scales within the series Guitar Scales Unleashed. This 99-cent app will provide hours of training and fun. Included in the app is a cheat sheet to help you figure out string and fret locations of the intervals within the minor scale that you will not find elsewhere. You can practice in training mode and challenge yourself in game mode with timer and score. The app can be downloaded on the App Store and Google Play. Check out the NANDI Method website. Please don't forget to subscribe and check out all of the other videos on our channel.